Hello, and welcome to ALEK's walkthrough video number 1. My name is Robert J. McKeown, and I'm very pleased to welcome you here today. These walkthrough videos are meant to help you get started. Most of the learning you're going to do is going to be on your own. That said, I'm here to help you. And this video in particular is going to give you some tools to be successful on your path to mastering algebra. If you can master algebra, your undergraduate career is going to be a lot smoother and a lot better, I promise you. Now, that said, the real number line is the beginning of university mathematics. And so that's where we're going to start today. Now, what do I expect from you? Well, I expect you to have your paper. Scrap paper is fine. If you want to have a notebook, that's fine too. If you want to print off the slides, if you have a printer and you want to print off the slides, by all means, complete the slides as we go and do your writing there. And then I highly recommend you use a pencil. I like a mechanical pencil that I can put the lead into. If you don't have a pencil, a pen is fine. But at university, you really want to get used to working with a pencil because on a test, you can erase your answer. So, without any further ado, let's get started. Here's our first question. So we're on ALEK's. We've got a question under the real numbers topic, and it's a proportionate form. The equation's in a proportionate form. The most important thing here is that we're being asked to solve for v. The unknown variable is v, and we need to solve for its value. So how are we going to do that? I've reproduced the question here on my slides, and I'm going to take it very slow, and I want to illustrate to you an important property of a double-sided equation, which is that as long as we perform the same operation on both sides of the equation, we do not change the equality. So what I'm going to do, maybe I'll start off by multiplying both sides of the expression by v. So let's see what happens when we do that. I've got 8 over 5 times v, and I'm going to multiply v by both sides of the equation. So I've got 12 over v here multiplied by v. What happens next? Well, you can probably see that v divided by v is just equal to 1. And now I'm left with, I could rewrite this as 8v over 5 is equal to 12. Now if I want to get rid of that 5, 8v over 5, I'm going to multiply both sides of the expression by 5. So I'm following the algebra rules. You can see that these 5s are just going to cancel each other out. And I'm going to have 8v is equal to 12 times 5. Well, that's like 12 plus 12 plus 12 plus 12 plus 12. And so I've got 8v is equal to 60. And v is going to be equal to 60 divided by 8. I divided 8 by both sides of the expression. And I know that 64 divided by 8 is equal to 8. So this looks like the answer is going to be 7.5. If I go back to ALEK's, I've got a little box here, and I'm going to put 7.5, and I'll click the check button down here and see if I get the right answer, and I did. So that was the right answer. The important thing for you to remember is those rules of algebra. Perform the same operations on both sides of the equation and solve for any unknown variables. Let's take a look at this question. We're being asked to subtract one fraction from another. And the problem we have is that since the denominators of both these terms are different, we can't subtract one from the other directly. So what we're going to do is we're going to use the lowest common denominator technique, and similar to in the previous question, we're going to multiply the numerator and the denominator by the same value, which means we're not actually changing the value of that fraction. So if I take a closer look here, I see that the simplest way for me to get a common denominator here is to take this 2 and multiply it by the numerator and denominator of the left-hand term, and I'm going to do the same thing with this 5 to the right-hand side. So let me clear that off. It's getting kind of messy. And so I've got 9 over negative 5, and I'm going to multiply the numerator and the denominator by 2. I've got 9 over 2, and I'm going to multiply the numerator and denominator by 5. Notice that I'm not worried about the negative sign. Now if I do a little bit of work, I'm going to get 18 over negative 10 minus 45 over 10. Now there's nothing wrong with me rewriting this equation as negative 18 over 10. Or if you prefer, I could factor out, which we'll learn about in a later topic. I could rewrite this as negative 18 over 10. And I'm going to subtract 45 over 10. Another way to write this is to say I've got negative 18 minus 45, and since the denominator is the same for both the fractions, I can just write them together like that. And I have negative 63 over 10. Shifting back to ALEK's, here's the question in ALEK's. It's the exact same question we saw before, and I'm going to keep it as a fraction. So I like to have it as negative 63, and then I'll click on this little character there, over 10. And I'll click on the check button, and we'll see if I've got the right answer. I've got the right answer, so negative 63 over 10. Now let's take a look at dividing fractions. So we have 15 over 14 divided by 7 over 8. So how are we going to get started? Well, it turns out that this thing is going to be equal to 5 over 14 multiplied by 8 over 7. Yes, that's right. If we're dividing, we're essentially going to flip the numerator and denominator and multiply them together. How can I show you that this is true and this is what we should do? Well, suppose I asked you what the answer was of 1/2 divided by 1 over 4. So you should be able to see, how many quarters fit in a half. Well, there should be 2, right? And if I follow that rule, I end up with the correct answer that there are 2 quarters in 1/2. So now let's go back to our problem from ALEK's. How can I do this without a calculator? Well, you can sort of grind it through in your head. One little trick might be to do this. So 5 times 8, that's on the multiplication table. If it's on the multiplication table, I generally know what it is. So I know that that's going to be 40. Now the denominator is a little tricky because it's off the multiplication table, so I find it a little more challenging. Well, one thing I could do is I could rewrite this as 2 times 7, which is 14 times 7, and that's going to be equal to 40 over 2 times 7 times 7, that's on the multiplication table, that's 49. And that's going to give me 40 over 2 times 49. Well, 49 plus 49, I know that that's 98. And now I've got 40 over 98. Well, if I divide both the numerator and denominator by 2, I'm going to get 20 over 49. So let me check my answer on ALEK's. So here we are on ALEK's, and we have the exact same question that I showed you on my slides. I'm going to type in the answer, so I'm going to leave it as 20. I'm going to press this little button over here, divided by 49, and if I check the answer, I see that I have the right answer, and that's how you divide fractions.